Okay, once mechanical has been loaded, we've got the geometry that applies to the solid and the fluid. What I'm going to first do here is I'm going to suppress the solid bodies, such that, the fluid bodies, such that what I have left is just the solid impeller. Just going to fit that on screen. And I'm going to make one change to the meshing settings that were created by default. I'm going to just increase the resolution of this to give it a finer mesh. Okay, I'm going to right click on the static structural object in the tree, insert, and I'm going to insert a fixed support. And this support would correspond to my shaft. So I'm going to zoom into this cylindrical surface here, select it, and click apply. Notice here that I've got an imported load object under the static structural branch in the tree. And this was automatically created as I made that connection in Workbench. I'm going to insert a pressure load coming from the fluid solution, and I'm going to scope it to the fan blades. So what I'm going to do is I'm going to select all the surfaces, and holding Control, I'm going to click on the surfaces that do not correspond to the fan blades. These ones here that you can see, I'm deselecting them. Okay, now that I've only got the fan blades selected, I'm going to complete this selection by clicking on Apply here. And now I've got to pick the source regions. So the CFD surface that corresponds to the fan blades, which in this case here is called wall fluid rotating. Okay, now that I've scoped the regions, I'm going to import that load. I'll right click on imported pressure, import load. And that takes just a moment here to bring that in from the CFD solution file. Okay, now that it's been brought in, what I could do is I could expand this branch here, and I could look at my transfer summary. This will give me some diagnostics related to that mapping. You can see here that 100% of the nodes were mapped. So it was a successful map. I can click on this imported pressure, and I can look at a contour plot of that imported pressure that's been brought in from the fluid solution. Now, there's one more load that I want to apply. I want to apply rotational velocity, and I want to apply it in RPM. So I'm going to go to my units, and I'm going to change my rotational velocity units to RPM. And now I'm going to right click on the static structural branch in the tree, insert, rotational velocity. In this case, I want this rotating about the y-axis. So I'm going to set this to be defined by components, and the y component, I'll set that equal to negative 3000 RPM. Okay, I've applied all my loads. To solve this, I right click on the solution cell, solve. And this takes just a moment to solve. Okay, and the solve is pretty much complete. What I'm going to do now is add a couple of post-processing objects. I'm going to right click on the solution cell, deformation, and create a total deformation contour plot. I'll also insert a equivalent von Mises stresses plot, and I'll evaluate all results. And now I can click on these objects to post-process them. There's the deformation, there's the stress, and there's a quick animation of that.